The agenda is going to be what is Java interface, need for interface in Java, syntax of Java interface, example of a Java interface. Then we're going to discuss interface nesting in Java, interface versus class, advantages of interface, and disadvantages of interface. What is Java interface? An interface is a container that stores the signatures of the methods to be implemented in the code segment. It's really hard to define interface because it's the meta of meta. It's basically a control object. And so you see these in projects where whoever is in charge needs to have a very high level of control of what everybody else is doing. Do you have to have an interface when you're doing programming? No. But if you're in a large project, you probably want one as director, or if you're receiving it, you might get the interface which you're supposed to use in your programming. So when we talk about the need for interface in Java, it's a total abstraction, and it's only the methods. We're not talking about any variables or anything like that, just the methods. You can do multiple inheritance, so you can inherit from different interfaces, and you can do loose coupling. And when we talk about loose coupling, you can think of 100 programmers working on a huge software package, and they really don't know what the other programmers are doing. They can't meddle with it, they can't mess with it. They have like a nice direct place they can do, and they have the information they need in the interface. So we'll talk about the syntax of the Java interface. The interface, then you have your interface name, and then you declare your constant fields, declare your methods, default method. And really, to understand this, we just need to take a look at an example in Java interface. And we're going to do the Java interface defined area, just kind of a fun little code. For this, I'm going to jump into Eclipse. And we'll go ahead and create a new package. There we go. And we'll call this interface. And we're going to go ahead and add in Java. And it won't let you do just straight interface because that's a reserved word. We'll go ahead and create that. And then underneath our package interface Java, we want to go ahead and actually add in an interface. And so we go underneath here, new interface. And let's go ahead and call this one, we'll call it area, interface area, and finish. So now we have our package and we have our area, and this is just the same package we did with our polymorphism and inheritance. So now we have a package, and we've added the object of an interface. And note that the interface is always public. You never have a private interface because it's a meta file. So it's always going to be accessed by other people and by other classes. And as we're creating these methods, this works just like you would any other method. I could easily put integer, and then we have maybe integer side 1, integer side 2. So you can see how you can do, like for the setup, this is going to be just like you do the rest of your class and the rest of your methods. But we're going to keep it simple. And we're just going to do void square, and let's go ahead and do public void rectangle. We'll put a rectangle in there too. So now we have a basic interface, in this case for area. One of the cool things about interface is I can go in here to create another, let me go back into my interface Java, and we'll do another new, another interface, and we'll call this area curves. I don't know, just making that up. So we have our area curves, and maybe in this one happens to be for a circle. So we have our curved areas. Let me just go back in here. And maybe we'll do not only a circle, but an oval. There we go. So now we have our circle, oval, or ellipse, depending on what you want to use on here. And I can go back to my area. And just like you can in classes, this extends area curves. So now I can also do the extends, or in the case of inheritance, same as in a class. Exactly the same. It just makes it easier if you have a hierarchy of stuff coming down in your interface. Now we'll go back in here to the package. Oops. We're going to go back here and create a class. And let's go ahead and do that in here under our interface. New class. And we'll go ahead and call it shape area. And so now we have our new class shape area. How the heck do we use our inheritance area in here? Well, we just go ahead and do implements area. And so once we do that, we now have area, which happens to extend area under curves. And let's go back in here to our shapes area, the class. And what I want you to notice in Eclipse is the shape area has an underlined red. And if I hover my mouse for it, it's kind of hard to see here a little bit. I'll give you some options there, which will say, bring in your implements. You're implementing area, but you didn't do anything with it. That is what interfaces are all about. It's about forcing someone to show an error here. Now in Eclipse, I have it set so it won't throw an error if I run the program, but it's going to tag it. So even if I compile it right now, let me just go ahead and run this, even though it doesn't do anything, it still has the shape area underlined. And then it comes up here and also puts a little exclamation point at the top when I actually do some actual coding in here. Let me go ahead and do that so you can see what that looks like. There we go. We'll put in our main and we'll initiate our instance of shape area. And we'll go ahead and run this. Doesn't actually do anything. It's going to compile all our different pieces on here. And you still see the shape area is got the red light underneath of it. When it pops up, it says, hey, you have some unimplemented methods. Make type shape area abstract, or different solutions on there. It's because we don't have the actual code. It's saying, hey, you were told to use what's in area and you're not using it. Again, this is all about being in control. And so we have in here, when we go back into area, oops, that's area curves. Let's go all the way to area. We have to have square and rectangle in there. And because this extends area curves, we also have to have circle and oval. And so when we put that in there, we have to do an override. Just so our package actually does something, let's go ahead and bring in the scanner utility. This is just capturing your keyboard. That's what that's for, the Java utility scanner. And then we're going to go ahead and do our override. Use the @ symbol, override. There we go. And then we go ahead and take a look at what we had in area. Well, in area we had square, so let's go ahead and grab the square. This, of course, is just being very lazy and not having to retype it. So we have our public void square, and then we wanted to do something in here. In this case, we want to go ahead and create a scanner for the keyboard. And we'll do a new scanner system in. And that's all that is we're going to do, we're creating an object so we can capture keyboard input and request information from people. And since this is a square, let's see, we're not going to get too caught up in the code here. Oops. There we go. And we'll go ahead and do geometry of a square and compile it and run it. It still lets me compile and run it. And you can see down here it actually says, hey, enter the length of the side of the square. We'll put in 5. And the area of the square is 25. So when we look at just this part, we have it accesses the square, prompts us for our input, does the math of the square, and is fully functional. But I want you to look up here. It still says, this still has an error. It still says, hey, you're missing the stuff in here. You don't have all the pieces you're supposed to have in here. So if we're missing the pieces in the implements of area, we need to go ahead and put those in. Now, we're not going to go through and do all the different areas and walk through each piece, And we're going to look at this. When I put in our rectangle, which is, we have the square and the rectangle, and then we had the circle and the oval, you can see that the error goes away. So I no longer have a shape area with an error on it. And if I run it, of course, will still compile. There we go. And if I come down here, forgot I got to put in something for the square. We could also, instead of square, just do whatever it is. You'll see that circle still functions, although it's just going to do a printout as opposed to what we had before, where it takes in all the information, computes the area. This is what implements is about. It's about taking all this stuff and pulling it in and forcing the programmer or the people in the team to use the different methods that they need for that particular class. And there's one more thing that we want to do, and I'm going to take this extends out here. And then we're going to go back to the shape area, and you're going to see it's going to give me another error on here, a slightly different error. And the reason is that I did overrides, but these don't exist, so they don't know what I'm overriding or what the setup is. And let's say instead of importing area, instead of having area inherit area curves, we could also just implement area and area curves. And then you'll see that the error then goes away when I run the compiler. There we go. And this should remind you of something we talked about in inheritance. Inheritance, we were discussing in classes how you have a diamond effect. You can't inherit from two separate classes. You can implement two separate interfaces. That means that if you have, you're the head of a project, you can now say, hey, this class needs these different pieces. So it's a very powerful tool, and it's one of the ways to force programmers to put in the modules they need and get around the diamond effect. Let's take a look at interface nesting in Java. Nested interface is a procedure declaring a new interface, either an existing interface or inside a class. And let's go back into here, a little play area. Let me just close these out real quick. And let's go ahead and add another package in, and we'll do new package. And we're going to call this, well, instead of interface, let's call it nested. Nested interface. There we go. Our nested interface package. Finish. And once we're underneath this package, we want to go ahead and add in an interface. And we'll put a new interface in it. And we're going to call this, this is going to be a little confusing, interface outer. And then in our interface outer, we're going to go ahead and create an interface inner. Let me put that in this. So here's our interface outer, here's our interface inner, and our void inner method. And then let's go ahead and add in a class, new class, and we'll call this the nested, oops, and we'll call this the nested IF for interface. And let's go ahead and finish that. So here's our class. And in our class, we're going to go ahead and import inner interface.interface outer.interface enter. Whoops, forgot I changed the name to nested interface for the package. So we're going to import from our package nested interface, interface outer, interface inner. And that just means that we're going from here's our interface outer, and here's our interface inner. You can create a stack of interfaces so that when you send the package out, instead of sending out 50 different interfaces, you can send one interface out with all the sub-interfaces embedded in it. And you can see it highlighted there. The nested if still comes up with an error because we haven't done our override. And we'll go ahead and put in a public here. And we'll just do initiate our nested IF class. I guess nested if. There we go. So let's go ahead and initiate that. We're going to have our object equals a new nested if. And again, if we compile it, and we'll go ahead and run it, and I'll do the compilation here, you can see that it compiles fine. It's not going to give you any errors. But when you hover over here, it says, hey, you need to add unimplemented methods. And you left some stuff out of here that you were told you're going to include, which was this interface inner. And of course, we can simply do that. There we go, make it look a little nice. Do our override. And then once we have our override, we need to go ahead and create the method. So it's telling us we have to have that method in there. We're going to get an error. And that was our inner method that we included. And then it's whatever we decide to do in here. Let's say we wanted to go ahead and we want to find the first 15 prime numbers. And our team in the back put together a little piece of code for that. It's always fun to throw something in interesting, so you're not just looking at a print. I did something really cool here. That can get boring after a while. So we'll go ahead and do integer. We're going to iterate equals 0, number equals 0, x equals 1, y equals 1. And then while number is less than 15, y equals 1, and we iteration equals 0. So forth. You can see here we're doing what is, if you divide, is there any leftover? If there is no leftover, then that means it's divisible. That's not a prime. Otherwise, if the iteration equals 2, system out is going to print the number, and then we're going to add another number to it and just keep looping through. So you can see right here, this is just a simple set of code. But there goes my error. My error is gone. That's what's important. We have our inner method. There's no more error on here because we've now included it. That came from our nested setup on here. And of course, if we're going to put a code in there to count the prime numbers, we should probably go ahead and do our object method and run that. There we go. And sure enough, we have our 2, 3, 5, 7, 11. There's our list of prime numbers. So just to kind of hammer it home, what is the difference between interface versus class? Interface, keyword used is interface. Keyword used for class is class. Interface does not include instructors, where class has its constructors in there. Interface stores only methods, only the method signature, where class has the storage of the actual definition. So just the signature versus a full method in there. There's no access specifiers in the interface, where of course there is. Access specifiers are needed in class. No data members, includes data members in class. No static members, includes static members in class. So think of the interface as being just instructions. They're instructions on methods. That's all they are. They say, hey, you have to do this as a programmer because your head of your department said this is what needs to be in here. Or maybe you have a very complicated code with a lot of the same pieces, and it says, hey, don't forget these pieces because we're going to give you an error if you don't. What are the advantages of interface? Well, using interfaces has increased the simplicity in programming. Some of the advantages are complete abstraction is achieved with no ambiguity. And that is very key. That is the whole thing. It's saying, hey, we need these in this class. You have loose coupling between the data and methods. So now your team can have what they need without having to go through and understand what the whole picture is. They can build on small pieces and really focus on it. It resolves the diamond problem. Remember from classes, you can only inherit from one class. Now I can come in and say, hey, these procedures, these methods all need to be in here. And I can have as many methods as I want in there. It resolves the complexities in defining dependencies. So again, you have this whole archive and it's almost like telling a story. This is what we're building. This is what it looks like. Disadvantages of interface. Using interfaces has some disadvantages. Obviously, the first one I look at is if you're working on a really small project, you've added a whole layer of complexity to it. So when you're working on smaller projects, you almost never see interfaces. The interface in the real world project is used either extensively or not at all. And so you will see, instead of an interface, they'll just send you a list of what you have to have in there. That's pretty common, but with the interface, it forces the programmer, so when it goes back up the chain and everything needs to be put together, and so it gets a little confusing because some people are like, oh, I got to use an interface or I don't. And the use of the interface can reduce the execution speed. You're adding a whole nother layer there where it has to look that information up. And so if you're doing like a huge multitask process and you're spreading it across multiple processors, and so now you have hundreds of these classes that are pulling in hundreds of these interfaces, that's going to add a little ding to your speed. And it might not be something you want to do there for a process like that, which is very different where if you're writing a game and each player and each module for their character, which has certain things they have to do, which is move left, move right, move up, down, and then they have all the new games always have a special thing they can do that has to be embedded into that class. So that concludes our interface. Thank you for joining us with Simplilearn. For more information, please visit www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.